Hello. You said hello.
You want to read it? Okay, go ahead and read it for us.
Up to 8 hours and then the flat rate $250 per day. Use the graph component as a function of knowledge situation.
Thank you. So, Seamus got a job as a private investigator, and he's charging $25 an hour for any amount of time up to 8 hours. And after that, he charges a rate per day. So we've got a little graph here. And we see we've got a point associated with 1, 2, 3, 4, and 5 on x. And then we've got something else that's between 0 and 1, a little segment. So what do we think this is? Is this discrete, continuous, or neither? What do you think, Patrick?
No, I would like to know.
Oh, okay. What do you think, Danny? Discrete? Why is this discrete? Yeah. So it's not quite discrete. We have some points. But what else do we have? Does anybody see anything? What do you think, TJ? Yeah, there's a line segment. From 0 up to a little bit into, a little bit close to halfway through 1. Sorry, I've got a picture of it. No, actually I don't. Sorry. But yeah, we've got a little segment. What does that segment represent for our story? Anybody got an idea? What do you think? The hours. So first, we're splitting this first day up into hours. And if you're using Seamus's services for 8 hours, and he's privately investigating people for you, or whatever they do, private investigators, then you're going to be charged an hourly rate. So that's a consistent slope, blank amount per hour. But then once you hit more than 8 hours, it's going to be 1 day, this amount, 2 days, this amount, 3 days, this amount. So those are points. They're no longer sloping and giving you an hourly rate. Everybody understand that? Yeah? It's kind of like the book problem we did yesterday. How there was a constraint where we couldn't have 1.5 books we were buying, or 2.25 books. So it's this kind of idea where it's per day after a certain amount. So that one is going to be neither. Okay, so now we're talking about linear functions. So what do we think about when we hear linear? What do you think, Keith? A straight line. Yeah, so linear functions are going to be straight lines. And nonlinear functions, what do we think that means? Non-straight lines. Good catching yourself. So not straight lines. So we are going to look at this little chunk of text at the bottom that says a nonlinear function. Anyone want to read that? Talia, I'm going to let you read it. So it says a nonlinear function has a...
A nonlinear function has a graph with a set of points that cannot all lie on the same line. An equation that represents a nonlinear function cannot be expressed in the form a by x plus b by y equals c. The function values of a linear function change at a constant rate for every equivalent change in the x values. The change in the function values for a nonlinear function will vary from equivalent changes in x.
Perfect, thank you. So, can anybody sum that up in like a sentence for me? What we learned? No, that was a lot. What's that ax plus by mean? Ax plus by equals c. Is that going to be a linear function or a non-linear function? Yeah, so that would be a linear function if we can write it in the form a times x plus b times y equals c. What are those a, b, and c? What do those represent? Because they're not variables. They represent something else that starts with a c. Adaya, what did you say? Constant. A constant. So a normal number. So a normal number times x plus a normal number times y equals another normal number c. Perfect. Ooh, sorry. So that's going to be our standard form for these. So that means it is linear, if I can write it like that. So we're going to flip onto the back. And it says, determine whether y equal to 4x squared minus the quantity 2x squared plus 3x minus 5 is an equation for a linear or nonlinear function. So I want to change this and see if I can write it in that form. But there's something I need to do first. Does anybody know what it is? Starts with an S. What do you think, Patrick? Not slope. Good guess, though. What do you think? Simplify. Good job. We got to simplify because we've got something that's not simplified here. What's not simplified? Yeah, so we've got 2x being squared. The product of 2 and x is being squared. So first we need to take care of that. So what is that? The quantity of 2x squared. We got to square both components, 2 and x. Any guesses? Lacey, what do you think? If I square 2 and x? 4? So what happens if I square x? How do I write that?
I'm not sure.
What do you think, Ryan?
I got an X and a little 2.
Yeah, so x and a 2 in the indices. So now we're looking at this, now that I've simplified. Is there anything else I can simplify? Anything else, any like terms maybe I could combine? What do you think? Yeah, absolutely. So what can I do with those? Alistair, what's that going to be? 4x squared minus 4x squared. 0. So I get 0. And everything else stays the same. Everybody with me so far? Okay. So I'm just going to write this without the 0 because that doesn't change anything. So my goal in this was to see if I could write it in this form, right? Oops. This thing's so touchy. So I want to see if I can write it in the form a number times x plus a number times y equals another number. So how can I start to make this happen? Get x and y on one side and keep my constant on the other. What should I do?
You said x and y on one side?
Yeah, what do you think I should do? Because I've got y over here, but my 3x is over here, and I want to bring it to the other side.
Wouldn't you just divide that by 3?
Not divide. Alistair, what do you think? We're trying to move x and y both to the left side. So how could I move that 3x over? What do you think, Taylor? Subtract it. I'm going to subtract 3x from both sides. Are 3x and y like terms? No. So I'm just going to write this negative 3x plus y. And keep my negative 5. So now I want to compare what I just wrote with my standard form. Is this in standard form? Is this a linear function? What do we think? Macy, what do you think? Does that look like it's in the same form as that? That's okay. What's being multiplied by y? What's the invisible number? A 1. So 1's being multiplied by y. That's my b value. What's my a value? What's being multiplied by x, Javen? Yeah, negative 3. So negative 3 is my a value. 1 is my b value. And what's my c value? Negative 5. C is negative 5. So is this in standard form? Yeah. We've got a number times x plus a number times y equal to another number. So this is in standard form, so it is a linear function. So we're going to do this one more time with determine whether 3x squared minus square root of 9 times x squared minus y equals 17 is linear or non-linear. Does everybody feel okay on that? Moving too fast? Moving too slow? Good? Okay. So 3x squared minus square root of 9 times x squared minus y equals 17. So, can I simplify anything here? Sienna, do you see anything here that could be simplified? Yeah, so square root of 9. We're not taking the square root of the whole thing. We're just taking square root of 9. Brinson, what's the square root of 9? 3. So I'm going to rewrite this, just replacing that square root of 9 with 3. So now, Holden, can I combine any like terms here? If I got 3x squared minus 3x squared minus y equals 17. Anybody got an idea? What do you think?
You can put together 3x squared and 3x squared.
Yeah. Yeah, so I got two values that have an x squared. So Holden, if I have 3x squareds and I take away 3x squareds, how many x squareds do I have? 0. So that simplifies to 0. And I got 0 minus y equals 17. So now, this one's a little bit trickier. Do we think this is in the standard form? Negative y equals 17. What do you think? What do you think? This is tricky. You don't think so? Let's see. What would my a value be? What's being multiplied by x? Nothing. So 0. So I don't have an a value. I've got a 0. What about b? What's b, Macy? Positive or negative? Negative. So b is negative 1. Carlos, what's my c here? What's my constant term? If I got ax plus by equals c. Oh. So I'm looking here. I said I had 0 in front of x, negative 1 in front of y. What's on my other side of the equal sign? Trevor, what do you think? What's my c? 17. So I got 17. So we're trying to find out if this is linear. What's up, Lydia? Yes. So a linear function we said is a line, right? So if I got negative y equal to 17, this is a linear function because this produces a horizontal line. I know this was a trick question, but this works. This does produce a horizontal line. Because what would my slope be of a horizontal line? Anybody know?
0.
0. Good job. My slope is 0 here, but this does produce a line, so it's a linear function. This is linear. All right, one more. Everybody okay on that so far? Okay. What if I had 0 for my b value? What if I had x equal to something? Would that be a linear function? Yeah, so what happens if I have a vertical line? What's the slope of that? I think I heard it. Undefined. So an undefined slope there. But we've got 0 as a slope here. Would this pass the vertical line test? It's going up and down. No, that wouldn't. Yeah, exactly. It's hit an infinite number of points. So that would not be a function. Okay, one more. On this, at least. So we got -5, -1, 0, 2, 3, 7. And then we've got -15, -3, 0, 6, 9, 2, 1. So, how do you think I'm going to determine if this is a line? We did something like this on the front yesterday. What do you think? Yeah, so we're going to try to find a constant slope because every linear function has a constant slope. Every line has a constant slope. So I'm going to look at the change in x and compare it to the change in y. So if I go from -5 to -1. So what's the change from -5 to -1? What do you think?
-4.
4. Yeah, my change is 4. I add 4. What about if I go from -15 to -3? Heat, what did I add to go from -15 to -3? 12. So for here, my change in y was 12. My change in x was 4. What about if I go from -3 to 0? Will, what am I going to get? What do I add to -3 to get to 0? 3. Anika, what do I add to -1 to get to 0? What's that change? How far is it from 0 to -1? What's that distance? 1. Perfect. So my change there was 1. So does anybody remember how I write slope? Is it y over x or x over y? Y over x. So delta y over delta x. Change in y over change in x. So for this point, for that change, my change in y was 12, and my change in x was 4. So it's going to be 12 over 4 is my slope there. For this jump, my change in y was 3, and my change in x was 1. So are these the same slope, 12 over 4 and 3 over 1? What do we think? Yes, why? So they are the same slope. Yeah, exactly. They're just further apart than each other. So I've got a constant slope of 3. So would this be a line if it has a constant slope? It would be continuous. So if something has a constant slope, is that a line? Is that safe to say that's a line? Yeah, it is. So this is a linear function. So this is a linear function. So we got one more on this page. Everybody okay with that so far? Okay. So now we got one more table. 7, and then 0, -1, -8, -27, -125, and -343. So let's figure out first a change in y. What's up? I did? What was it? Oh, sorry. Thank you. Appreciate you. Okay, so let's talk about our change in y here. So Leah, what's my change in y if I go from 0 to -1? Yeah, so it's a change of -1. I'm decreasing by 1. Brinson, what's my change if I go from 0 to 1? 1. How about Anthony, what's my change if I go from -1 to -8?
7, -7.
Yeah, -7, perfect. Sienna, what's my change if I go from 1 to 2? 1. So, now I'm going to ask you. My change in y here was -1. My change in x was 1. And then my change in y was -7, and then it was 1 for x. So, are these the same slope? What do we think? -1 over 1 and -7 over 1. Is that the same number? No. So is this a linear function? No. Not a linear function. Not a linear function. All right, so that's everything for 2.2. Yeah, everything for 2.2. So now we're going to look at that paper we got today that says 2.3 intercepts of graphs. We all got that one? Sorry, I put it out a little bit late. So it looks like this. Hey. That one was discrete because we had dots for that. Because it wasn't, we can't have a fraction of a book, so we decided it was point by point, so it had to be discrete. Okay, anybody remember what an intercept is? My football people should know.
Oh. Wait, just an intercept? Oh. Return the ball. Intercept is when they make contact with each other.
Yeah, exactly. So my
Like it.
well, in football, I think it's like an interruption almost. Like you take the ball from where it was supposed to be going, basically. Oh, I like your shoes. So we've got x-intercepts and we've got y-intercepts. And Patrick said it's when it collides with something. So when it makes contact with something. So what do we think an x-intercept is going to be? Is that going to be colliding with the x-axis or the y-axis? What do you think? X-axis. So if I've got some kind of graph like, just do a line. If I've got a line like that, my point where I intersect x, right here, that would be my x-intercept. So I'm going to have a value for x and 0 for y, right? Because I'm not up or down in terms of y. I'm just sitting at, maybe it's 3, 0. Maybe that's 3 points over. Then my y-intercept, that's going to be where I intercept my y-axis. So here it might be 0, -2, something like that. Everybody okay with that? So we want to look at the graph and see where am I hitting x and where am I hitting y? Where am I hitting those axes? I'm going to erase that. Oops, that didn't work. So looking at those definitions, anybody want to read those off? You got it, Danny? Thank you. Yeah, go for it if you want to.
The intercept of graphs is points where the graphs intersect an axis. The x-intercept is the x-coordinate of a point where a graph crosses the x-axis. The y-intercept is where the y-coordinate of a point where a graph crosses the y-axis. A function is positive when its graph lies above the x-axis. A function is negative when its graph lies below the x-axis.
Perfect, thank you. So when is my graph going to be positive, Lacey?
When it's facing this way.
That's different. Yeah. No. So where does it need to be lying? Either above or below something. Ryan, what do you think it is?
Above this line.
Yeah, which line is that? Is that the x-axis or the y-axis?
Hold on, I learned this last.
You got it. One's x and one is y.
The x-axis.
That's the x-axis. So if my graph lies above the x-axis, like in this region, is positive. If it's below, that's when it is negative. Perfect. Thank you, guys. So for this number 1, we want to use the graph we're given to estimate the x and y intercepts. So we don't actually have any numbers on here, but let's just use the spaces and estimate. So which one is going to be my x-intercept? Is that when I touch this line or when I touch this line?
The bottom one. The one going left to right.
The one going left to right, the horizontal. That's my x-axis. So wherever my graph passes through there, let's put a dot right there. And let's try to figure out what that is. Is that one going to be 0, something, or is that going to be something, 0? Something, 0, because I have an x value, but I don't have any movement in my y. I'm sitting on the x-axis, so I have 0 right there. How far over does it look like it is? What point do we think it's on? 3? So we're sitting at 3. 3, 0. I might need to make that smaller. So now, what about the other one? Where's my other intercept going to be? Where do we think? Vertical? About where do you think it touches? Where does it cross? About 6? So what am I going to write there? Am I going to write 6, 0 or 0, 6? What do you think, TJ? 0, 6. Perfect. Yes. So now we want to talk about when it's positive and when it's negative. So is it... I'm learning. I'm learning. I want it to be perfect, but it's not going to happen today. Maybe one day. You guys are my guinea pigs. I'll figure it out. I'll be great next year, but this year I'm struggling with the tech. Okay, so when am I positive? What's my rule? I got to be above or below something. What is it, Anika? So above the x-axis, this is where I'm positive, when I'm above this. And when am I negative, Seamus? Below it. So yeah, below it, that's going to be when I'm negative. But above it, I'm positive. So we're looking at x values. We want to go from left to right on my graph and see, okay, when am I below? Am I below the x-axis on the left side or on the right side?
On the right.
On the right. So as I'm moving from right to left, I'm negative, negative, negative. Oops. Right there, I start hitting positive, right? I start going above the x-axis. So what's that turning point? Where's that point right there?
That's 3, 0.
3, 0. 3, comma 0. So when x is equal to 3, that's my turning point. So when I am bigger than 3, I'm going to be positive. Or sorry, no, I'm going to be negative, right? So when I'm x equals 4, x equals 5, x equals 6, I'm down here. My line keeps going down. But when I'm smaller than 3, I keep going up. So 2, 1, 0, I keep increasing. I'm above the x-axis. So the function is positive when x is bigger than 3. And I'm negative when x is smaller than 3. We all okay with that? We see that? Okay. So, everybody good on that one? So for B, we want to do the same thing. We want to follow that x-axis and see where I'm hitting. So looking at this, if I'm traveling along the x-axis, right there, that is where I hit, right? What do we think that point is? How far left am I? Brinson, what do you think? How far left am I? -2. So I'm sitting -2 in the x. And what in the y do I have? What do you think, TJ? Oh, you already did this one. Yeah, so here I'm -6 down. So what do I put for the other spots? 0, because I've got 0 in the y for my x-intercept, and I've got 0 in my x for my y-intercept. Sorry, I wish this marker would write smaller. Maybe I'll do this. I got -2, 0, and 0, -6. Can you guys see that okay? Okay. So when is my function positive? When am I above the x-axis? What do you think? When x is bigger than 3. Ooh. Not for B. What do you think? Where's my graph above? Talia, where's my graph above the x-axis? So when x is bigger than -2, that's this way. But when am I shooting up above the x-axis? -6. So my graph's going like this. And I'm bigger on that side of it. This is where I'm positive. So this is my point -2. And if I'm going left, are these points smaller or bigger than -2? Smaller. So when I go smaller than -2, that's when I'm in this region. That's when I'm above the x-axis. So when x is smaller than -2. Everyone good with that? It clicked? So now I want to know when it's negative. So if it's positive when it's this way, smaller than -2, when am I going to be negative? Which side is tipping negative, TJ? When it's bigger than -2. Perfect. So when x is increasing, getting bigger than -2, that's when I'm dipping below. So that whole region, my x values are going bigger than -2. So like right here, x is at -2, we've got 0 in both. X is at -1, I'm down here. X is at 0, I'm down here. X is at 1, I'm down here. And it keeps getting smaller and smaller. But when I'm smaller than -2, like -3, somewhere up here, -4, it's up there. It's getting bigger on the x-axis, increasing into the x-axis, or above the x-axis, I mean. Okay, so everybody good on that one? Okay, this one's a little bit interesting because why? Does anybody know why it's interesting? What do you think? It's like a U. What do you think?
It's hitting 3 points.
It's hitting 3 points on my axes. I've got 2 x-intercepts. Does anybody know what this is called? There's a certain kind of function that makes this shape. It starts with a Q. You got it? Quadratic, yep. A quadratic produces this shape on the graph. Perfect. So, what is one of my x-intercepts? Anthony, what's one of them? One of the points where I hit. What do you think that point is?
3.
Oh, positive 3. That is 1. So that 1 is positive 3, comma 0. 3 in the x direction, 0 in the y. And sorry, I forgot to print with another one. I also didn't even give you guys space for your name, which I apologize about. Hopefully you write your name on it. What about my other x-intercept? Christy, what do you think my other x-intercept is? Negative 4. So negative 4, comma 0. Perfect. And now, this is a little tricky. When am I above the x-axis? Anybody got an idea? When am I above the x-axis? When am I positive? What do you think?
Negative 4 and 0 and x-intercept, not a y.
Oh, sorry. I'm so sorry. I'm glad you saw that. So we didn't even finish that part.
It's really cool.
It is, right? I like this thing. I'm just bad at using it. Sorry, I forgot to ask. Where's the y-intercept? Pete, where's the y-intercept? What point am I hitting on y?
Oh, the y?
Mm-hmm. Negative 12. So 0, comma negative 12. Sorry, guys. I hope nobody's writing in pen. So my x-intercepts are 3, 0 and negative 4, 0. But now I want to talk about when I am below the x-axis and when I am above it. Will, what area am I below the x-axis here? So there's my x-axis. What points am I below it?
What do you mean?
This point, where am I? Where's my function below it?
Over here?
Yeah, so right here it is. What about over here? Is it below?
Yeah, it would be below, but there's also above.
There's also above, but when I'm below, I've got that little red area. All of this is below the x-axis. So between which two x values am I below it? Pete, when am I below it? Which 2 points is that between? Here and here. Right there and right there. What are those 2 points? Negative 4 and 3. So when x is between negative 4 and 3, I'm negative. When x is between negative 4 and 3, that's when I'm negative. That's when I'm in that red zone below. What about when I'm positive? How would you describe this area, Carlos? When I'm bigger than what value? What is x there? Let's look at that. 3. So when x is bigger than 3, I'm positive. So when I'm increasing, when I'm at 3, 4, 5, I'm above the x-axis. What about on this side? Because I'm above it here too. What point does that start? Marielle, what point does that start when I'm above the x-axis over here? Negative 4. So am I getting smaller than negative 4 when I go left or bigger? Smaller. So at negative 4, I'm above, well, I'm at 0. At negative 5, I'm above it. I'm up here at negative 6. I'm probably up there. So my numbers are getting smaller, but my graph is rising higher above the x-axis. So when x is greater than 3 over here, I'm bigger, and when it's smaller than negative 4. So when x is smaller than negative 4. Everybody good with that? I feel like it's hard to communicate these ideas without being right on everybody's paper. But whew. Anybody want to read the sports one? Any of my football players? I was deciding because I have some kids in second period who play football. I was either going to put one of your names or theirs, but I put their name because I put Seamus as the detective. Okay, go for it.
Sports graph shows the height of the football field for each second. X, that, everything. Use the graph to estimate the negative x, the x and y intercepts of the function. Where the function is positive and negative, and intercept the meanings in the context of the situation.
Perfect, thank you. So we want to talk about where I intersect the x-axis and where I intersect the y-axis. Holden, where am I hitting the x-axis? What point do you see it touching that bottom line here? 9. So when x is 9, y is 0. That's my x-intercept. So 9, 0. What about when I am intercepting the y-axis? 0, 4. You got it. 0, 4. So that's when I'm hitting my y-axis. That's my y-intercept. So, now we want to talk about when it's positive. So this is my x-axis, right? Going this way. When does this graph dip below it? When am I below the x-axis? Anybody got a guess?
Is it a 4 or not?
That's a 4. Sorry, I tried to distinguish it. What do we think? When am I below this line? Where do you see the blue line dipping below that? What do you think? When do you see the blue line dipping below red?
It doesn't.
It doesn't. Because my y-axis is my height, right? If I was going below 0, my football would be underground. And unless we're playing in, I don't know what kind of stadium you'd have to be in for the football to go below where the person threw it. Maybe on a slope. I don't know. But no, normally you throw the football. If nobody catches it, it lands on the ground, right? So we're hitting 0 in my height. So f of x is never negative. When is it positive, though? When do I see it above? Between what two x values? What do you think, Talia? What do you think, Anthony? What do you think? I want to know when it's positive. So between what two values do I have this graph for x? Where do I start?
0.
I start at 0. Where do I end?
9.
9. So between 0 and 9. So f of x is positive when x is greater than 0 and x is less than 9. That's when I have it positive. So what does that point 9, 0 mean? If he's throwing a football, my height is 9, my time is 0. What does that mean? Or sorry, it's 4. So my time is 0, my height is 4. What's that? Yes. So if I'm throwing a football, no time has passed and the football is at 4 feet high. Has the ball left his hand?
Probably not.
Probably not. So maybe he's holding it and he's about to throw it. And then what about my x-intercept at 9, 0? When would my height be 0? When it hits the ground. So after 9 seconds, he's got the ball in his hand, he throws it, it hits the ground. So that x-intercept, that's when it hits the ground. Sorry, yeah, that's when it hits the ground. Hits the ground. And the 0, 4, that's before the throw. Before the throw. Okay. Really good work today. That's pretty much everything. And then we've got a quiz tomorrow. But I'm going to give us time to review. There is homework online for you guys to try.